Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope everyone is doing all right out there. I don't know the title for this lesson. It doesn't matter. But what does matter is our two goals for this lesson. And our two goals are the following: an explanation of what undefined means in math, and an example of how changing rules changes outcomes in math. So we're about to start in our geometry section. And geometry always starts off with the concept of undefined. So I have a little lesson I like to share about what it means to be undefined in math, and then this segues into how do rules create the mathematical reality that we know. So let's go ahead and jump right into our first goal. And I have an example of undefined, and it's 100 divided by 0. And we call this undefined because we cannot divide by 0. So whenever you divide by 0, you just say it's undefined, and that's it. End of story, we move on. But what does it mean to be undefined in math? Let's actually investigate that. It means that there's no agreement about what a concept is or does. There's a disagreement. Back to 100 divided by 0. There's a disagreement about what 100 divided by 0 is equal to. People don't agree what divided by 0 is, and that's why we have any number divided by 0 is called undefined. People argue about what that means, and so for the rest of this first part of the lesson, I want to try to create the situation where we have the disagreement about what it means to divide by 0. So we've had this ice cream example, and remember the act of division is scooping. When I scoop, I'm dividing. And this tub of ice cream is sized in such a way that if I take 100 scoops with a normal spoon, I empty the tub. Probably crying while I eat it. For some reason, people cry when they eat ice cream out of a tub, but that's another issue. So if I use my normal spoon, I take 100 scoops, my tub of ice cream is done, and I've cried a bunch. If I use a spoon that's larger than my normal spoon, that means I take less scoops because I'm scooping more with every scoop. And we've discussed this before, and I'm still crying. If my spoon is smaller than normal, I have to take more scoops because every time I scoop, the spoon is smaller. I'm taking less ice cream, therefore I have to take more scoops. But this is still not dividing by 0. So here's where the dividing by 0 comes into this. And this is the disagreement. How many scoops can I take if the spoon has no size? Let me write that down. It must be so boring watching me write. How many scoops can we take if the spoon has no size? And this is the disagreement. This is dividing by 0. And there's two camps on this. And they both make valid points, and that's why there's a disagreement. That's why nobody can agree what it means to divide by 0. Remember, the act of scooping is dividing. One camp says, that's nonsense. It's 0 because you have no spoon, therefore you can't scoop. It's 0. That makes sense. That's a valid argument. It equals 0. Right? People will argue, and they're right. They have a point. It equals 0 because you're not taking anything. Therefore, it has no value. But then on the other hand, the people who disagree with that say, no. Remember, the act of scooping is division. And since our spoon has no size, we're not taking any ice cream, and so we can keep scooping forever, which means that we can take an infinite number of scoops. So the counter argument to that is it's not equal to 0. In fact, it's actually equal to, and this is the symbol for infinity. Okay, it's actually equal to infinity because you don't take any ice cream and you can in fact scoop forever. So this is the disagreement. Is dividing by 0 equal to 0, or is it equal to infinity? That's an example of a disagreement in math, and that's why we would call dividing by 0 undefined. Okay? So the next part of this lesson, I'm going to pick a side for an argument. I'm gonna say, you know what, this side is wrong, we all agree on this. And the way I want you to think about it is the following. This being undefined is an ingredient in the cake we call mathematics, our mathematical reality that we understand, we're familiar with. And what that means right now, a result of this, is that our number line is flat. Okay? I'm going to change this ingredient. And if you change an ingredient in, for example, a cake, you get a different cake as an outcome. So by me picking a side to this argument, making this now defined, I'm going to get a different result. So I'm going to show you how this plays out. Is it valid? I don't know. But it hopefully gives you an insight to how rules create rules later on or have implications in your mathematical reality. So I'm going to hit pause, erase all of this, and set up the next situation. I'll be back. I'm back. So here we are in the second part of our lesson, our second goal. And I want to go over how an example of changing rules changes an outcome in math. And so we saw previously why dividing by 0 was undefined. Some people felt that it is equal to 0. Remember our scooping ice cream example? There's no scoops because there's no spoon. That's a valid argument about dividing by 0. Other people also felt that, correctly, that, well, it's actually infinity. Since there's no spoon, you can't scoop, but you can scoop forever. So this is why dividing by 0 is undefined. There is a disagreement about what it means to divide by 0, so we call that undefined. For this next part of the lesson, let's define this. Let's come to a consensus, an agreement. Let's say that moving forward, that we agree that it's equal to infinity. And everybody who felt that it was equal to 0, you have seen the error of your ways, and you asked for forgiveness and feeling that silly conclusion that it meant that there was no scoops, you apologize. Us infinity believers accept your apologies. We move forward in harmony, and let's see what happens to math now that we've changed an ingredient. Remember, if you change an ingredient in a recipe, you get a different result. So we're changing an ingredient to our recipe. Let's see how it changes the result. So, okay, I just said this. We changed the ingredient. Let's see how this changes what we know. So first thing it's going to change is vertical lines are no longer undefined. They're now called infinite slope. All right, and that's going to play a part into my next argument. And what I want to do is I want to remind you guys that there's multiple ways to represent a concept. And sometimes when we look at a concept in a certain way, we are able to reach a conclusion that we might not have seen prior. So here, just to remind you of the fact that we can represent concepts in multiple ways, we have the ordered pair. We could write the ordered pair in function notation. So if I plug in a 3, I get back a 2. I could write it as part of a table where my x value is 3, my y value is 2. I can put it on a graph. I go over 3, I go up 2. And finally, I can put it in a mapping diagram. There's 3, and it goes to 2. Okay. But these are the ways that I can represent the same concept. Plugging in 3, getting back 2. But I want to do this using slopes of lines and numbers. I want to break my numbers up into 4 different slopes of lines. I want to make my positive numbers be positive slopes. I want my negative numbers to be a negative slope. I want infinity to be a vertical line, and I want 0 to be a horizontal line. All right, so let's write that out so we have that in front of us. Oh. So a vertical line, this represents the number infinity. A horizontal line, this represents the number 0. A line with positive slope, this represents the positive numbers. and a number with negative slope, this represents the negative numbers. Let me do this again. Negative numbers. There we go. All right, there we go. So my numbers are represented, my 4 types of numbers are represented by a vertical line, horizontal line, positive slope line, and a negative slope line. And prior to this, there was only one number that separated positive and negative numbers. It was 0, right, on a flat number line. So let's look at some things here. I'm going to draw just an example of just a graph. That's not a very good marker. Let me try this again. All right, draw a graph here. I think that's okay. That was still not very good, but it'll do for today's argument. Okay. So here I have a graph, and you don't really need the graph, but it's helpful to visualize. So here I have, this represents positive numbers, this represents 0, this represents negative numbers, and to go from negative to positive, you see that I cross 0. To go from negative to positive, I have to cross 0. So the question I want to ask, because I changed an ingredient, because we now have a different recipe, is there another way to go from positive numbers to negative numbers? Do I have to cross another value? So remember, to go from positive to negative, I had to cross 0, which is what we're used to. But is there another way to go from positive to negative? And the answer is yes. I can go from positive to negative by crossing an infinity. Let me say that again. I can go from positive to negative by crossing infinity. We now have 2 numbers, 2 locations that separate positive and negative numbers. And we're getting this new result because remember, we changed an ingredient. And when you change an ingredient, you get a different result. You get a different cake. So now, try and visualize what the number line looks like. It's no longer flat. We're no longer in Kansas. Dorothy? I think that's what it was in the movie. Our number line now must not be a number line. This must be the shape of our number line in this new world. So, am I ever going to test you on this? No. Is this work or not? I don't know. But what we can do is we can ask, what would happen in this world if we ignored this and accepted this? What would that mean for our number line? What new results would we come out of this? But what I did want you to see is how initial rules create later outcomes. And that's going to be very important when we get to geometry and we start arguing from a set of initial rules. And these initial rules allow us to create later outcomes. So this is, I think, a very interesting way to introduce the concept of beginning rules, change later outcomes. So hopefully this made sense to everybody out there. Again, I hope everyone is doing okay out there. Have a good day, everybody. Bye-bye.